Hello, my dear learners. We are back into the discussions. Now here we have another video where you need to learn something about the multiplication of the algebraic fractions. So we talk over multiplication. It means the division will also be done at the same time because the procedures of which are not all that much different. So in short, we're going now to discuss the issues pertaining to how we can multiply and then divide the algebraic fractions. Right, so with me here, I have some examples that I'll use to explain the procedures on how best you can multiply and divide the algebraic fractions. Right, so like here, we are given the first example. The three, of course, we'll manage to discuss all of them at the end. I'll just give an exercise that we're going to write. If we fail with time, I'll still leave example C as a group work where you are think are just been groups. If you don't have group, still you can work it individually. Right, so here we have got the first one where we ask to simplify. That's a squared plus 2a minus 3 over a squared minus 16 multiplied by a plus 4, then over a squared plus 8a plus 15. So let's see that one. I'll write it here. We have, let me have the space at least, which is at least extended. A squared, that's a minus 2a minus 3 over, that is a squared minus 16 multiplied by a plus 4 over, that's a squared minus 8a plus 15. Right. So that's what we have here. Now, how do we go about the issue about now multiplication? Right. So as I said earlier, no matter what type of operation are we going to meet, the first thing is consider it about factorization, and then you move forward. Right. So here we still are going to assess the expression that makes up the fractions, as we have been doing in the previous videos where we were doing the operations by addition and subtraction. So going now to assess, can this one be factorized? Can this one be factorized? That one be factorized? That one be factorized? If it's possible, let us do it. Right, so you'll be able to see that the top expression for the first fraction can be well factorized. You can follow the same procedures of grouping method of factorization and find that on the top there, if we try to factorize this one, we are going to get that's a that talk over minus that is 3 and then a plus 1. It gives us that one here, right? But now it should be a plus 3, then a minus 1. It gives us what? That's this expression here, right? Maybe for all of us, we are what maybe doing together. Sometimes some you have just forgotten the procedures we did in factorization. So here it'd be like if I consider a squared minus 2a minus 3, we talk of a multiplied by this one, by a constant negative 3 to have got negative 3a squared. Then look for the factors of negative 3a that can give you what? Negative 2a. So here you find that the factors of this one that can give you negative 2a are negative 3a and what? That is what? Positive a. That's what you have here. Because when you say this multiplied by this, it will give you this, and this one plus this one, it will give you negative what? Negative 2a. So by what we have been doing, it means what you get from here, it means just we're going to write this one down to have got a squared. Instead of writing that, you substitute for the factors here, which are minus 3a, then plus what? Plus a. Then you end up with negative 3 as such. So what we have, you group the terms into two groups, first pair and the second pair. Then find the common factor that can divide in each one of those pairs. So like for the first pair, we have got a, open bracket, a minus 3, and then there we have got what? Positive 1. So which is plus 1, a minus what? 3. At the end, we have got factors a minus 3, then a plus what? 1. I know you're already conversant with the issues about factorization. So which means when you are factorizing this one out, the solutions you get are a minus 3 and also a plus what? A plus 1 as such. Right, so here we are. I'm going to write it, that's a minus 3, and also here I've got a plus 1 as such. Right, now where do we go? Let us look down here. This is just the difference of two squares. So what we have here, it will be like difference of two squares, as I've earlier pointed out in the previous video, that you just have to find the conjugates. That when you multiply, they give you a difference of two squares. And from this, what we have is just like a minus 4 and also a plus 4, like that. Right. Now, where do you go next? We look at that part of the fraction. Can we do something with a plus 4? You'd find that here for a plus 4, there's nothing that you can do there. What we have is something else. Just a little bit. Oh, here is positive. Let us use for the positive here. Let us go for this one. Let us use the positive. Of course, for the negative, this is just correct. But now, let's get back for the positive. For the positive, positive, yes, positive 2. Positive 2. Right. Procedures remain the same. For this one, if here is be positive 2, we still have to factor by the same method, and what we're going to get is just like a plus 3 and again a minus 1. The same procedures. So here we have a minus 4 and then a plus 4. Right. So it's the same. There it can be positive or negative, but here we are trying to discuss about the operations, how best we can factorize and proceed our operations as such. Right. So for the positive 2a, these are the fractions that we have. A plus 3, then a minus 1. Right. Let's proceed. What about here? There's nothing we can do, or even the common factor is not there. So what am I going to do? I'll just write a plus what? 4 as such. Similarly, as I was factorizing this expression here, by grouping method, you will also be able to do the same and try to factorize a squared minus 8a plus 15. So when you factorize this one out, the factors that we're going to get here are a plus 5 and a plus 3. Right, a minus 5, a plus 5, and a plus 3. They'll give us this one here. When you multiply this by this one, it will give us a squared minus 8a, then plus what? 15 as such. Right, so once we have done this, what else that is it that we're going to do? Right, now by the very first part that we discussed in the very first video, where we were simplifying the algebraic fraction to the simplest form, we'll just divide the numerator and denominator by the common factor. So we apply that same procedures here to check on the numerator and the denominator. Do you have a common factor? Or say, do you have common factors, so that we can simplify the expressions here? If they are there, let us apply that same procedure. So here, if I look at the numerator here on top for both fractions, I find that here I have got what? That's a plus 3. And down here, I also have got a plus 3. So which means a plus 3 will cancel with a plus 3 like that. And here I also have got a plus 4. Down here, there's also a plus 4. So it means a plus 4 will cancel with another a plus 4 like that. At the very end, if I check, keep on checking, I find here I've got a minus 1. But here there's no a minus 1. So it means this cannot be simplified with any one of the expressions down here. And don't go for the shortcut to say a and a like that. No, don't have such type of maths. So which means what we are meaning up here is just like on the numerator, we have got a minus 1. And on the denominator, we have got a minus 4 and a plus 5. So it means a minus 4 should multiply with what? A plus 5. So we write it this way to say a minus 4 and then a plus what? 5. You don't necessarily have to clear the brackets, but you can leave it just like as binomial they are, like that. So it means the solution for this is a minus 1, and then down here we've got a minus 4, then multiplied by a plus 1, a plus 5. Right, so this is our final answer to example A. Right, so from what you can see here, you'll be able to realize that everything that we do here, the most important operation that you have to master here, mostly, is the issue about factorization. Once you know how to factorize, it means the rest of the story is not all that a problem. You know how to cancel up the terms which are like, you are able to know how to come up with the common factors. You simplify as such. Right, so we have done the first one. Let's go now to the second problem, which is B. Right, question B, we are having expressions of those kinds, right? So here is B, we are having m squared minus a squared over, that is m squared plus bm plus am, then plus ab. Right, so here we have got what? That's a divide by, that is the m squared minus 2am plus a squared over, that is c m plus b c. Right, so I have this situation here. Now it's about division. How you do about division in the algebraic fractions is the same way you have been doing with the fractions, which are vulgar fractions, which have got numbers only, the integers only, where you always consider that the divisor, this is the divisor, this must get into this fraction here. We need to at least convert the expressions here. This comes on top, this one comes down, like that. That's the way we do the division. But if it was multiplication, it'd be just like that. You don't have to upset the word, the expressions. This one comes on top, this one comes down. But rather, since we're dividing, let this one be the numerator, and the numerator comes now at the what? At the denominator. But the first thing you do is, please consider it's about factorization. But maybe like here, since the division has got its own instruction, let us consider this one first of all by writing this one on top and this one down, then we go for factorization. So what I'll have here, I have m squared minus a squared over m squared plus bm plus am plus ab, and the sign always changes to multiplication. Now the cm plus bc comes as the numerator, and the m squared minus 2am plus a squared comes as the denominator. So it goes like that. It's about division. Now what next? Let us factorize where necessary. You can see here, these are also difference of two squares. So the answer to that comes in as the m minus a and m plus a. If we were to factorize m squared minus a squared. Similar down here, this is a little bit simplified. You just go by grouping here. You group these two terms, you group those two terms. Right. So it means this is the one group, this is another group. What do you do then? Find a common factor. In short, use that process of the grouping method of factorization and try to factorize this expression down here. So if you factorize this one, you have factors like, just to be brief here, we have factors like, that is, we got some, we have got a, m plus b, and then also have got a plus a. I think I already demonstrated on how you do the factorization, gentlemen. We don't have to even waste time. You group these terms, you group again those terms, find the common factor, and you go like that. But here, you also do the same. Here, try to factorize this one and that one. You see that here, how you can factorize this is simply by just dividing a compound factor there, which is just well spotted as C. So which means here you divide the common factor, which is C, getting into Cm, you get your M plus B as such. Coming to the denominator of this fraction, the same method of grouping method, only that we don't have enough space here. Would have also explained that, but now I know that now you are conversant on how to factorize. Why should we be doing the same now and again? Right, so if you try to factorize this one out, this expression m squared minus 2am plus a squared, you are going to obtain factors such like m minus a and m minus a. That one is just like a perfect square because it has got identical factors, a minus a minus a. So you can just do the factorization by the grouping method. You're really going to obtain these factors here. The same as we have done this way by grouping, you're really going to obtain these factors here. So as students should have that type of what? At least a practice. Now, once that is done, what else do we do? We follow the previous example, what we have been doing there. We would now check, say, on top and down there. Do you have the common factor that can simplify? If yes, please let's do it. So let's try to check. On top here, we have got m minus a, m plus a, m plus b, and a c. Do you have such expressions down here? If they're there, let them cancel. So like here, I've got m minus a. This one will cancel with m minus a. And here I also have got m plus a. So here there's also m plus a. So this one cancels with this one here. Here I also have got m plus b. This m plus b will cancel with m plus b as such. Right. So once that one is done, it means what remains will form the solution. On top, what are we remaining with? We just remain with C. Down here, what do we have? We have got m minus a. So the solution to this is this C over m minus a. So the solution to this one divided by this, the answer we have is C over m minus a. Right. So I repeat here, how to multiply and divide are almost the same procedures, but what differs is just like here, we only convert the what? The expressions. What was numerator comes as denominator. What was denominator comes as what? Is numerator. But each about factorization is maintained so that you have to simplify the terms and come up with the factors which can simplify each other on the numerator and denominator, like here m plus b, m plus b, m plus a, m plus a. You cancel them out. Right, so this is the end for example B. So go through it and fall further than just like similar with the first one. Right, the last one is the example C, where I think here I'll just be very quick to explain it to you because the procedure of which have already been highlighted up there. Right, so what I want you to do is you try this one now. It's a combination of operations, division, and multiplication. Right, so I'm trying just to figure it out. Should I do it for you or should I just review it for as an assignment? I think as students, you should have that one as an assignment because the way I look at it, I'll just be repeating the same things, right? Maybe just in passing, you still have to factorize where possible, as we have been doing up here. You check, can you factorize this one? If you can do it, do it. If not, leave it. Can you manage to factorize that one? Yes. If not, leave it. The same here. You try to check, can you factorize the expressions? Right. So if you cannot factorize it, leave them as such. But if they can be factorized either by grouping or else by just dividing by common factor, do it. But remember, where you are dividing, we have to what? At least convert the what? The expressions. What was numerator comes as denominator. What was denominator comes like a numerator. Right. So here you do how you have to do that what? Operation. This one comes top, this one comes down, and this one you leave it like that. So try at least to simplify this one out and try to come up with this solution. So for C, I'll just give you a solution here. Right. So for solution C, right. This is the solution you get from there. You must get a squared over a minus b, and then what? A plus 3b. Right. So I've given you the solution here. Can you try to do as we have done up there for the two examples, the first two? You do the same and try to get this answer. Right. So if you be able to obtain this answer, it means we are really together and the things are ticking. Right. So by this, we should also at least say bye in this video, where we just had to at least get to know how best we can multiply and how we can divide the algebraic fractions. So here again, I also comment on it to say the most important process to be considered here is the issue about factorization. Remember always, before you start doing the operation, factorize the expressions where necessary. Right, so I also have to thank you for being together. I know by this we are able to follow each other until at the very end when we be able to conclude our topic. Right, so in the next discussion, what we do now, we are going to familiarize ourselves with the equations. There's some equations which have got algebraic fractions, so it'd be like, how can we solve such type of equations? So in the next video that we'll have, they are going to discuss such objective. How do we solve problems? That's the equations involving algebraic fractions. Thank you very much for being together once again. Remember, please do always update yourself. Play the videos now and again, starting from the beginning up to the last, where we are going to end this topic. The link is down here. Very simple to have it. Thank you very much.